Okay, welcome back. Let's continue this course. Okay, in this section, I want to start from standard contracted rectangular weir, and this weir type is like this figure, and the flow value depends on L and H factor. And as I've mentioned previously, H is the head of the weir, and L is the length of the weir, and P is the height of the weir crest. Okay, let's select the unit and enter the required inputs for H, for L, and for weir height, and the parameter B. And press calculate, and you can find out that the discharge value equals 32.7 cubic meter per second. And when you click on the description, you can find more information about this weir, and as you can see, the accuracy of this discharge coefficient of this weir is about it range between -5 and +5%, and the accuracy of measurement obtained by this equation considerably less than that obtainable with V-notch weirs. And also the limitation and restrictions of this weir type is presented here, and as you can see, the height to head ratio, I mean P per H, must be higher or larger than 2, and the ratio B per H must be larger than 2, and also the length to head ratio L per H must be higher or equal than 3. Okay, another standard surface rectangle weir is presented here, and in this case we don't have the B parameters in both sides of the weir, and the formula which is used for calculation of flow just based on L and H. And first of all, select the unit, head H, length L, and the height of the weir crest. Okay, this weir lead to this value. And also if you click on the description, you can find more information about the accuracy of discharge coefficient of this weir type, and also the limitation of this case. However, I highly recommend you to study the US Weir water measurement manual, because in this manual you can find more information about different types of weirs ranging from Cipolletti to WES or other types. Okay, the last weir type is the WES spillway design. You know, in most large dams and in most case studies, this weir type is used in more case studies because it is based on more practical equations. And for designing the spillway based on this method, you can find some information and enter input and required dataset. But first of all, before that, I want to show you some description about this weir type. You know, based on WES standard types, we have 4 different, for example, A, B, C, D weir types, and each of them has different upstream slope of the weir, and also for estimation of the curve, downstream curve of this weir, you should use this equation, and x related to x direction, and y is the elevation or y coordinate, and it depends on k and n. Based on each of these case, you can find you can find suitable values for k and n. For example, if the slope of upstream face is vertical, the k value equals 2 and n equals 1.85. While for other upstream faces slopes, you can find different values. Let's assume that we want to estimate the flow value for a WES Weir with the upper slope value about vertical, and it leads to k and n equals 2 and 1.84, and the model uses this formula for estimation of the curve of the WES value, and other information are extracted based on WES spillway. And also, I think, let me click on this. The example of WES Weir is presented here, and you have a curve section, and also it connected to the other part of the hydraulic jump section. Okay, finally, we have a Weir with this figure, and you can find a curve section, a linear section, and also finally at the end of the Weir we have a curve or circular section. And here we can find a numerical test for this case. Okay, let's come back. Okay, I think at this time this section does not work accurately, but for using this case you should select SI metric and then enter the flow value, for example 50 cubic meter per second, and enter this value for crest length and upstream water surface elevation, for example as 100, and the channel floor elevation. Let me enter this value, and the WES spillway shape I want to choose the option A, and then press calculate. And unfortunately at this time this option does not work. If you run this section accurately, you can see this information is calculated based on the input data sets, and if you plot these values in Excel environment, you can find the shape of Weir based on WES standard. And you have a linear section, you have a curve section, and it didn't use the circular section at the end of the Weir. However, this is the overall output of this practical and most widely used Weir. And also in this section, different information related to this Weir type is presented, and also an example is presented for using for your case studies. Okay, let's close this section. I hope this video is practical and useful for you. If you have any question, just keep in touch with me. Have a good time. Bye bye.